So today we are going to learn about Java thread pool with the live code with the demonstration. So threads are the power of the Java because you can do multiple things in multiple threads, but that is also the weakness of Java. The reason is when you're not able to utilize threads properly, you would get out of memory exceptions, and then there's a lot of resources which gets consumed, and then it slows down the server and ultimately shuts it down. So understanding about thread and utilizing it in a very effective way is essential if you think you are a good Java programmer, and I'm going to help you learn this concept. My name is Asim Jain. I am an instructor on Udemy, and I have also authored a book on software design patterns using Java 9. So before we move ahead, I would like you to visit this GitHub repository and download the code which we are going to use now. So I'll quickly guide you through how to do that. You would just go here, and this is my repository. You can always star the star it, so it would be easy for you to next time get there. So it's in the algorithms and data structure in Java. This has ton of code which will help you. So it has a lot of algorithms, but today in the what we are going to learn is in Java concepts. So this is where you will find a package called as thread pool. So this will be the code. You can clone the repository or download the code, but this is what we are going to use to understand the concept today. So let's get back. I hope you will take a pause and download the code, and then let's try to understand. So what is a pool? What happens is whenever you're trying to generate a thread, I have the code already set up, which we will learn run. So basically first let me run this code, and then I'll try to explain you the concept of how this actually behind the scene, how it is working, and all the things about it. So pictorially or graphically, let's understand that if you spin up a thread, threading is a way by which you can do multiprocessing, which means if you have a big process and you want to divide it in multiple threads so that you can achieve the result faster. If you would run it sequentially, it would take long time. But if you split it in 5 parts, probably you will save, 1/5, like you will finish it in 1/5 of the time or 1/4 of the time. So thread management takes time, and it's an intense process. If you start at the beginning, if your task is big enough and there are a lot of threads, so instead of doing good, they can do bad, as I told you initially in the introduction. So how to manage this is, the capability of your hardware. Based on that, you can provision how many threads you need actually, and then those threads can be pre-created, and you can put the task. So in this example, I have the task which are queued up, and in the thread pool there are 3 threads. So these thread, once they will finish with the job, they would take the next items in the queue basically, and then that's how this thing would happen. So that you are not working in a single thread, you already have multiple threads, you are achieving that, but you don't have that many thread which can kill your system. So you define a predefined pool, and then each thread is reused, which means if you will start a thread and then stop a thread and then again start a thread, it would take a lot of resources and energy. In these cases it won't, because the thread is initiated once, and then it would be reused throughout. So what I am going to do, how this entire thing works. So we have a public class in this, which is sample thread pool, which has a main method, and this is where you have the thread executor service, wherein you define the predefined number of threads in Java. After that, I am running a for loop to simulate the number of threads, like whatever are the tasks. So for example, I have 10 worker tasks. So let's see what our worker task is doing. This is just a simple Java class which implements runnable. And then when you run it, it would print the message, whatever is the number of the message. and process the message, and then it would end. Now, just to simulate the real time thing, we are making the thread sleep for 200 milliseconds, which would be roughly 2 seconds. So here you are creating 10 threads, and your pool is having 5 capacity. So it would first execute 5, rest 5 it would put in the queue, and it would, as soon as any thread is available, it would try to reuse that. So here if you see the console output, so first 5 threads basically pick up these tasks from 1 to 5. Then as soon as the the job started getting finished, as soon as they getting finished, the next available thread from the pool picked up another task, and ultimately everything got finished. So what we did here is we spinned up 10 threads. Let me run it again first. So right now we have 5 threads, and then all these 5 threads ended. Then next chunk of threads came, and then next chunk of thread ended. So this is how the pool is working. Now to understand the code, when we spin up these 10 threads, and then this for loop created basically 10 instances of the worker like this, and then it passed it on to the executor.execute, which means it's the thread pool manager. And then based on this, it know how much capacity or how much thread it is having. So it did the thread management, it did the pooling, it did assign the task to particular thread whatever and whenever it was needed. So that is how. Now we did thread dot shutdown because I had to finish up the thread executor once it comes. So whenever this thread executor has no task, it would shut down. And meanwhile it is not getting terminated. This will run it in the for loop, and that's how until it's not been terminated, you will see that the process will stay. If you don't have this, then as soon as the 5 threads will finish, your program will shut down abruptly. That we don't want. So that is why this piece of code is there. And finally you see finish all basically finish all the threads. So this is how the pretty much simple program of thread pool is here. Just to summarize it again, basically we created a predefined number of threads which were waiting in the pool, and then there was the task queue. From the queue, the thread pool picked up one after another task and executed it. So what we did is we reused the thread to save the the resources which were being used for the creating threads time like each time. So I hope you like this, and then let's get connected on social media. I am here on all the platforms. My name is Asim, and thanks a lot. Take care. Bye.